going to continue working with matrices. Again, you have your I will statements. You will and you have, and especially today, we're going to organize and represent data. You will identify the dimensions, and actually you already have identified the dimension and elements of a matrix. Okay, you have already added and subtracted matrices. You have multiplied by a scalar multiple. And now today we are going to emphasize on creating matrices to solve systems. Now, we're not solving them today, we're just going to create matrices. We will create matrices, and then our next step will be to solve the systems. But before we can create matrices, we are going to understand how to organize and represent the data within those matrices. Now, what I will tell you is there are, I believe, 2 or 3 different places that you are going to need to pause the video and do some things on your own. So be sure you put this stuff into your journals. Okay. Now, again, this is a repeat of what we have already discussed. What are matrices in math? A matrix is a set of numbers arranged in rows and columns. And remember, a matrix is rows by columns. And there has to be corresponding or consistency in your matrix. There has to be consistency in the way your matrix is set up, okay? The entries in the matrix is called the elements, okay? Now, matrices are or can be created for tons of different reasons. Now, please understand there's an infinite amount of possibilities on how we can use matrices, and I'm just barely scraping the surface, okay? Okay, so we are going to do a quick recap. Matrices are classified by their dimensions. Dimensions are rows, left to right, columns, up and down. All of the columns can represent something. All of the rows can represent something. It's just a matter of how you decide to make those arrangements. Regardless of the decision you make, you have to be consistent. And I believe you will see what I mean by consistency when we start to practice. Now, we're going to be given some football information on a team called Cowboys. With the information that we're given, we are going to create or set up a matrix. Okay? Now, they've already told us we are supposed to name a matrix C. So, C is going to equal, and then we're going to have a matrix set up. The given information. So, I'm going to grab my pad, and I'm going to write down the important things that I feel important, okay? Or what I'm going to need to categorize, make my matrices, okay? Game 1, okay, the first quarter, Cowboys football points, 4 games, 1 through 4, so I have 4 games, and the points are given by quarter. We have 4 quarters in a football game, so we have 4 games, 4 quarters. All right, game 1, all right, so game 1, quarter 1, I have 6 points. Second quarter, I have made no points. Third quarter is 13 points. And fourth quarter is 3 points. Okay, game 2, my first quarter is 21 points. Second quarter is 18. Third quarter, I didn't score anything. And fourth quarter is 7. Game 3, the first quarter is 14. Second quarter is 28. Third quarter is 6, and the fourth quarter is 0. Game 4, last game. The first quarter is 0. Second quarter is 0. Man, we weren't doing very good, were we? Third quarter is 35. Fourth quarter is 17. So what we're going to do, and I have this information, and I've written it down, but I also made it a little smaller up here. But all the information is the same. I'm to create matrix C. Again, we've already had the lesson. C equals. This is my matrix. And I'm going to open up my matrix. Now, what I'm also going to do, just for your benefit, now we generally wouldn't do this, we would just have C equals. But I'm going to show you, I have 4 games and 4 quarters. I'm going to make a choice. My rows are going to represent my games. So row 1 would be game 1. Row 2 would be game 2. Row 3, game 3. Row 4, game 4. So my rows are going to represent my games, okay? And I would not do this if I'm making or if I'm giving an answer on a piece of paper. I'm giving this right here for explanatory purposes. So this is row 1, this is row 2, this is row 3, this is row 4, okay? All of these rows represent my games. Rows represent games. Let me make this clearer. Rows represent the game number. Game number 1, game number 2, game number 3, game number 4. I would not have anything in between C and equals and my first part of the matrix. I just numbered them for your purposes. Again, we do not number these when we're creating the matrix. And I will erase those at the end so you can see what the actual matrix should look like. So if I have my games, I also have my quarters. And keep in mind, we do have 4 quarters. We are going to create a 4 by 4 matrix, but our matrices can be different sizes. It doesn't always have to be square. This just is coincidental, doesn't happen all the time. So my rows are the games, so my columns are the quarters. So what quarter it is represented by our columns, and you do it in order. This would be my quarter 1, this would be quarter 2, this would be quarter 3, and this would be quarter 4. I have 4 games and 4 quarters. Each entry will represent the points earned in that game during that quarter. So in quarter 1, first quarter, 6 points, and I will enter them in black. First quarter, 6 points was earned. First game, first quarter, 6 points. And again, I wouldn't have this 1, 2, 3, 4 here. I wouldn't have this 1, 2, 3, 4 there. This is for explanatory purposes only. So I earned 6 points in the first quarter of the first game, okay? In the second quarter of the first game, I had no points earned. In the third quarter of the first game, I had 13 points earned. In the fourth quarter of the first game, I had, where's it at? I had 3 points earned. So this entire row represents the points earned in the first game by quarter. Okay, and if I wanted to, I could have another column that represented the total points. And to get the total points, I'd have 6 plus 0 plus 13 plus 3. So we'd have, what was it, 25? No, 22. We'd have 22. So now we're gonna go in, but I wasn't asked to create that. I was only asked to create the statistics, points per quarter per game. So now I'm ready for the second game, game 2. In the first quarter, and I have already written down my information, in the first quarter, whoever made 21 points. In the second quarter, 18 points were scored. In the third quarter, no points were scored. And in the fourth quarter, 7 points were scored. And truthfully, again, I could add all of these up and see the total score. So currently, if I wanted to even compare game 1 and 2, we scored a lot of more points in game 2 than game 1. Okay? On to game 3, because we have the first 4 games. Game 3, the first quarter was 14 points. The second quarter was 28 points. The third quarter was 6 points. And the fourth quarter, I guess we got tired, or maybe we put some people in for experience, but no points were scored. And once again, if asked, we could determine what game had the highest score, in games 1 through 3. Which game did we score the most points? Just add all these up, because all of these represents the points first quarter. Last but not least, we're gonna do our fourth quarter, okay? Or not our fourth quarter, our fourth game, I'm sorry. In our fourth game, Gee, quarter one was 0. We didn't do very good. Quarter two was 0. Well, maybe we knew that we could come out later. I have no idea, okay? And then in the third quarter, apparently we found our energy and we got 35 points. In the fourth quarter was 17. Now, with this knowledge in your journals, I want you to write down, you should have this example in your journals, but I want you to tell me which game did the Cowboys score the most points. Now, don't forget to tell me which one of these games did the Cowboys score the most points. Was it in game 1? Was it in game 2? Was it in game 3? Was it in game 4? Okay, which one of these games did the Cowboys score the most points? Now, I almost forgot, I don't want to forget, I told you that I would erase this stuff because this was explanatory reasons only, okay? And actually, even this was for explanatory reasons only. I'm gonna scoot that back over. This would be the proper answer in the form that I was asked to create it, okay? C equals, C represents Cowboys, Cowboys equals, and this matrix represents that given information. So, on the next slide, okay, you need to be sure and create this. This is on your own. I'm not gonna check it on this video. However, you will be responsible for having this information. So be sure that you create it. Be sure you determine over at the side or whatever, how many points were scored in every quarter, because you may be asked which game did the fewest points occur, which game did the most points occur, and this does not represent the Cowboys. This is a different team called the Falcons. So be sure you have this in your journals. On this in particular matrix C, it has a little different twist, but same song and dance, same application. I see that this is over here just a little bit, so I'm just gonna maybe scoot this over just a little maybe. Okay. But we have a toy maker. A toy maker makes handcrafted stuffed animals for children. Each doll and stuffed animal comes in 3 various sizes, small, medium, and large. Okay, so apparently we're talking about some items sold, so maybe inventory. He makes them by hand, and there's 2 different types. We have dolls and we have stuffed animals. So I have dolls and stuffed animals, okay? Each doll and each stuffed animal come in 3 various sizes. So I have 2 different items that I sell. Each item that he sells comes in 3 sizes, small, medium, and large. Now it gives me, for the first quarter in the toy maker's fiscal year, 2021, his records reflect the following sales information: 5 small dolls, 10 medium dolls, and 18 large dolls. Then we have 12 small stuffed animals, 22 medium stuffed animals, and 9 large stuffed animals. Okay, so again, I'm supposed to create matrix T with this given information. It is different than the information that I was given on the Cowboys. It's a different request. So again, we have to keep in mind, we have 2 different items, inventory, or whatever, that we make or we sell. They are dolls and stuffed animals, okay? Each one of them come in 3 sizes. So I have 2 different items. I'm just gonna put items. I have 2 items, and then I have 3 sizes. All right, my matrix is supposed to be matrix T, maybe for toys, T equals. Well, my brain, how I wanna do it, I have 2 different items, so I'm gonna have 2 rows. I'm gonna have a row of dolls, and then I'm gonna have a row of stuffed animals, okay? Now my columns are gonna represent the sizes. We come in 3 sizes. So I have 3 sizes. So I'm gonna have my small, medium, and large. All right, again, for your purposes, you can go, okay, this is dolls and this is sizes. I'm not gonna write those down. I will put this over here. I'm gonna put row equals items, okay? So that's my items, and I'm gonna have 2 items. I have dolls and then I have stuffed animals. Okay, now I do have 3 different sizes. My columns are going to be my sizes. My columns are my sizes. So I'm going to have, that's an E. I have small, medium, and large. Okay, so here I'm going to take my information. Each doll and stuffed animal comes in 3 various sizes: small, medium, and large. Okay, small, medium, large. Dolls are going to be the top, and stuffed animals are going to be the bottom. All right, so here we go. His records reflect the following sales information: 5 small dolls. Dolls are top, 5 small dolls. Then I have 10 medium dolls, and then I have 18 large dolls. So dolls are here. Okay, then I'm on stuffed animals. I got 12 small stuffed animals. I sold a lot more, stuffed animals than I did dolls. 22 stuffed animals, medium, and 9 large. So again, does he sell more dolls or more stuffed animals? We could, knowing how the matrix is set up, we could determine which he sold the most of in the first quarter. So now that we've had these applications, we're going to look at system applications, because that's where we're building to. And again, we are not solving those systems today. We are setting them up. Now, we could say this represented all sorts of stuff. The truth is it can. I could say, okay, my rows here are going to represent clothes. These are shirts, these are pants, these are jackets. So shirts, pants, jackets. And each column could represent, I don't know, the number of them that I have. You know, I have a negative 6X shirts. I have a negative 5Y, negative 5Y shirts here. It just depends on, I can't think of something off the top of my head, I'm so sorry. It depends on the information that we're given. Now, these were just given our system. The truth is, we can solve this system by hand. It's going to take us a minute because we have to eliminate variables, and we're going to have to do it over and over again. Once we find one variable, we're going to have to plug it in for the other, and then we can find the third variable. But it does take work. Fortunately for us, we do have our graphing calculators, and we're going to go through that on how we can solve this system by the touch of a few simple buttons. But before we can even consider solving the systems, we're going to have to set them up. Now, we're going to set up something called, and I'm going to write it in green, an augmented matrix. Augmented matrix. Now, what an augmented matrix means is that I've got some information on the left and then new information on the right. You'll only have one. So this could be total sold or cost, and this could be an amount, all right? Now, when we set up our augmented matrix on paper, again, we have to have consistency. Now, we have 3 different variables. Those are going to be my columns. This will be my X, this will be my Y, this will be my Z. So, X, Y, and Z represent my variables. Always, always put your variables in alphabetical order. I do not care if the equation you're given is in alphabetical order. Your matrix is to be set up in alphabetical order. A, B, C, Q, R, S, T, U, V, don't care, alphabetical order. And then each row represents our actual equation. Now again, and I just want to preface, this is not an augmented matrix. That's what we're going to set up. And when I say an augmented matrix, I'm going to draw this line right here. And this red line represents all of my equal signs. So everything on the left is one information, and this could be our cost, or this equals or something, and we're going to have one thing on the right. This is what an augmented matrix looks like. And again, this will be X, Y, Z, and this is going to be my total. X, Y, Z equals what I'm given. All right? So in equation number 1. I list only the coefficients, number in front of the variables. And you always keep your sign with the number. So I have x, y, z, negative 6x, negative 5y, and a positive 3z equals a negative 29. Not too hard. X, y, z. X, coefficient of, I don't see it, it's an understood 1. 1x, I write it in my matrix. Negative 6y, a positive 4z, and then I have a negative 4. Last equation, negative 4x, just the coefficients, number in front of, positive 2y, and a negative 3. Let's not forget, I have my negative 5 over here. So this is an augmented matrix. Now what I want you to do is I want you to set this augmented matrix up. Be sure that you have it in your journals. So we're gonna actually number these. This is gonna be number 1. I expect you to have number 1 as an example in your journals, but I expect you to have number 2 in your journals. Okay, you write down the equations. Okay, this is your problem. Number 2, this is your problem, and you set up the matrix. Okay, we're gonna do this again. Okay, another one. This right here is my matrix. Again, I've got 1, 2, 3. I have 3 different ones, and I've got RST, RST, I got ST. I don't have an R here, so I need to be careful. So when I'm setting up my matrices, here it is, and again it's an augmented, so I'm going to draw my number. Row 1 is my first equation. I have a negative 4. Row 2, not row 1. I have a negative 4. That's an R. S is a negative 3. And T is a negative 5. Equals a negative 28. Then in this one, I have 1 R. I have 6 S's, 5 T's, and a 4. This was my hiccup. I only have 2 variables. Well, if R isn't there, what number do I multiply to get rid of complete, and multiplication, not an added inverse, to make it completely go away? 0. 0 times R is 0. So I have 0 R's in this equation, negative 6 S's, negative 5 T's, and a positive 2. And this would be number 3 example. Okay? And you need to be sure and label them examples. Example 1, example 2, example 3, example 4. Okay, so this is the augmented matrix created from this set of systems. So what you're going to do, be sure on your own, this is example number 4. Be sure that you have example number 4 in your notes, in your journals. Be sure that happens. Now, this is on your own. So be sure that you pause this, you write these down, and you create the augmented matrices. Now, in some of our examples, we named our matrices, like back here, they told us to create matrix T, they told us to name it T. But here, they're not asking us to name it. We are setting these systems up so that we can create them. Okay, these are your setting up your own matrices. So we're going to number these. These are your actual problems. Practice on your own. So I told you to be sure and label your others as example 1, example 2, example 3, example 4. Well, these are problems. Well, number them. Actually number them. This is problem number 1. This is problem number 2. So pause the video. Be sure you write these down. This is problem number 3. And this is problem number 4. Because you're setting these up on your own. Okay? Be sure they're in your journals. And then I appreciate your attention, and I want you to have a wonderful, wonderful day.